Okay, good evening, everybody. Can you all hear me? Hello, good evening.
Good evening.
Yes, good evening. Good evening, everybody. Can you all hear me? Can I proceed?
I can hear you loud and clear from Zambia.
Okay, welcome from Zambia. All the way
Thank
from
you.
Zambia.
Exactly.
Okay, my name is Sholakpe Adetutu Adeyemi, and I'll be taking you briefly on water analysis. We all know water is a chemical compound composed of two hydrogen atoms covalently bonded to one oxygen atom. Its chemical formula is H2O. It is one of the most essential substances for life and is commonly referred to as a universal solvent due to its ability to dissolve a wide range of substances. Water exists in all three physical states on Earth, as solid and liquid and as gas, water vapor. The importance of water cannot be overemphasized. I'm digressing a bit from the slide. Water is life. Water is living. Water is continuity. So the importance of water, having water that is safe for human consumption, having water that, is free of, pathogens that can cause disease is of utmost priority to the world, to humans, and even to animals. So I'll continue. Water plays a crucial role in various biological and physical processes. It is the primary constituent of most living organisms, that is inclusive of humans, and makes up a significant portion of the Earth's surface. Water is involved in numerous vital functions, including hydration, transportation of nutrients and waste in living organisms, regulating body temperature, and supporting various ecosystems. Are we together? Hello, can you still hear me? Hello?
Yes.
Okay,
Yes, we
are we
can.
together? Okay, excellent. So, without water, humans will not be able to perform so many bodily functions. You understand? Without water. So water is important. Water is important for photosynthesis. Water is important for indigestion. Water is so important, in living organisms. And its importance cannot be overemphasized. Yes. So the unique properties of water, such as this high specific heat capacity, thermal conductivity, and surface tension, make it essential for maintaining the Earth's climate and supporting life as we know it. It is a vital resource for humans and other living beings, and access to clean water is critical for human survival and development. So we all know about what is happening, the global warming that is happening. Research has shown that layers of ice are gradually becoming what we call the solid part of water that is supposed to keep the earth, regulate the temperature of our planet, is gradually dissolving. It's gradually dissolving and increasing sea levels. You know what that means? So the earth is getting hotter and hotter, and the ozone layer is getting more and more depleted. So we are experiencing harsher climates. When we should have the rainy season, we are not really, it could tarry. Sometimes it could be longer than it should. Sometimes it will tarry, all of that, all because, we are having, this, challenge that we have now as in the earth. So water analysis refers to the process of examining and evaluating the physical, chemical, and biological properties of water sample. It refers to the process of examining and evaluating the physical, chemical, and biological properties of water samples. It involves a series of tests and measurements to assess the quality, the composition, and the suitability of water for its intended use, or to identify any potential contaminants or pollutants therein. When we talk about water, drinking water, underground water, groundwater, water from the river, from the stream, water, you have water from different sources. So the quality of each, is different. The water I'm going to drink now, the quality of water I'm going to drink now will be different from the quality of the water underground or water from the stream that's probably been contaminated, You know, I don't know how many of us, you know, have stayed in the village before. You find that at one end of the river, someone is washing. At another end, somebody may be pouring into the water or weighing into the water. So at another end, you have people fetching water. You know, they will just put their clay pot and just do a little wishy-wishy motion and, you know, pick up that water. That water will be totally different from the water you and I drink. I don't know whether I'm communicating, because that water is actually not meant for drinking. It is meant for washing of clothes, and also the quality will be different. Because like I said, some people have put into the water, so definitely you're going to find organisms like salmonella or E. coli or anything that comes, you know, organisms that stay in the intestine. You find it in the water. Those that are baited in the water, soap and all those constituents have already contaminated the water. I don't know whether I'm communicating. Hello, are we together?
Yeah.
Yes, okay.
We are together now. We are together.
Okay. So I just want to be sure that we are all following. So, like I said, it involves a series of tests and measurements to assess the quality and the composition. The composition of water varies. The quality of water, depending on where it is sourced, they varies. Suitability of water for its intended use, or to identify any potential contaminants or pollutants present. Okay, so water analysis is typically performed in laboratories equipped with specialized instruments, equipment, and methodologies. You have something, when I say methodology, we have something called a standard operating procedure. We call it SOP. Most labs, you will see it, once you enter into the lab, you will see it is usually laminated. They will print out, okay, take you know, maybe some mils of water using a particular glassware, you know, put it on your workbench, introduce also mil of, you know, chemical into it and all of that and all that. That's for the chemical lab. But for the microbial lab, they will tell you to pick your water sample, you know, using being mindful of the fact that the vessel you are going to use to pick that water sample is sterile. What you are going to use to cover that water sample, the vessel, is also sterile. Everything is sterile, so that you are actually checking for microorganisms in the water and not microorganisms that have already adhered to the container with which you picked your sample. So you find out that picking of sample for microbial analysis will be different from picking of sample for chemical analysis. You can just use anything, any, you know, vessel, any glassware, you pick your sample. But for microbial analysis, you have to you would have sterilized, that's your glassware. You would have sterilized the foil that you are using to cover it before you now take it down to wherever it is you want to get the water source. And even that water source, if you are, for instance, you are getting the water source, the sample from a tap, you have to sterilize the nozzle of that tap. You first of all use a tannoy, and you can use a matchstick. You just light it up. It will temporarily, it will, like as if it's gonna fire. You are just trying to sterilize the nozzle so that the microorganisms that have adhered to the nozzle, maybe by virtue of somebody carelessly touching it or whatever, it will all have died. You understand? So you are picking water into your sterile vessel, covering it with another sterile cover, and taking it straight to the lab. Okay, so the specific parameters and tests conducted in a water analysis may vary depending on the purpose of the analysis, the type of water being tested, e.g. surface water, groundwater, drinking water, and regulatory requirements. Okay, so we go to common parameters analyzed in water analysis. So you have the physical parameters. One, you are going to be checking the temperature. You are going to be checking the pH, that's the acidity or alkalinity. You can use a pH meter for this. Anybody can do this. You understand? So you check for the acidity or alkalinity. Ideally, the water should be neutral. Then you check for the turbidity, clarity or cloudiness. Water that is pure, that is for drinking purposes, should be clear. It should not be cloudy at all. If it is cloudy, please do not drink. If it has particles, please do not drink. Do not indulge in something that could harm you. Then the color and the odor. The color should be clear, and the taste also. The taste should also be clear. Taste as well should be. People say tasteless. It's actually insipid. It should. Tasteless is not the word to use. The water for drinking purposes should be insipid. Yes. So then it should be without any odor. If the water has a particular smell, then the water is bad. Something is not right. maybe the filtration. I'm talking about when you are preparing the water for maybe for production in a manufacturing company or for drinking purposes, something is actually not right. So it should go through a filtration system if it's going to be used for a manufacturing company, say a company that is into drug manufacturing or food manufacturing or drinks manufacturing and all. So then secondly, the chemical parameters, dissolved oxygen, conductivity, total dissolved solids, the nutrients, nitrogen, phosphorus, heavy metals, lead, arsenic, mercury, organic compounds, pesticides, herbicides, VOCs, and inorganic ions, chloride, sulfate, and fluoride. So microbiological parameters. You are going to be looking at your total coliform and E. coli. Now, the coliform and E. coli is actually, those are organisms that you majorly find in your guts, as in your alimentary canal, that come out in your poo. So when you see such an organism, because you know where it is domiciled, it's just like normal Staphylococcus aureus now. That one is domiciled. You find that on your skin. You can find it just about anywhere. But once you are seeing E. coli, you know that it is an indicator straight away for fecal contamination. Nobody wants to drink water that has fecal matter in it. Poo that has fecal matter in it, no matter how tiny. So it means, you should not be taking that water. You should not have any amount of E. coli in water for drinking. Then heterotrophic plate counts, HPC, for assessing total bacterial counts too. That should not be above 10 colony forming units per mil. It should not be above that. Then the pathogenic organisms, one of the pathogenic is E. coli and coliforms, but we are looking at specific bacteria, viruses, and parasites. Usually for the lab, we assess for bacteria, usually bacteria. So it could be Staph aureus. Do you have Staph aureus in the water? Do you have Klebsiella? Do you have Salmonella? What do you have? What is inside that water? What are the pathogenic organisms that is, or even Pseudomonas aeruginosa? You understand? So all of that could cause, life-threatening ailments. So the methods used for water analysis can include various laboratory techniques and instruments such as spectrophotometry, using light absorption or emission measurements to quantify the concentration of specific compounds or parameters, chromatography, separating and analyzing different chemical components in the water sample, such as your gas chromatography or your liquid chromatography. Then atomic absorption spectroscopy, AAS, determine the concentration of heavy metals by measuring the absorption of light at specific wavelengths. Inductively coupled plasma mass spectrometry, analyzing trace elements and heavy metals by measuring their ionization and mass to charge ratio. Microbiological culturing and testing, we mentioned that's under my microbiological parameters, using selective media and growth conditions to detect and quantify specific bacteria or other microorganisms. For instance, now in the lab, you are checking for microbial, you want to do microbial analysis. I've already spoken about aseptic ways of collecting water samples, for instance. Now upon collecting that water sample, you take it straight into the inoculating chamber. Inoculating chamber, you insert it into that place. Then you would have prepared your agar or your media. So normally for E. coli, we have for coliforms and E. coli, we have different media that you can use to test. We have McConkey agar. There are so many. You have nutrient agar to check for heterotrophic plate count. You have the EMB. You have so many that you can use to check for specific bacteria. So you use selective media and growth conditions to detect and quantify specific bacteria or other microorganisms. So you would have mixed it up and put requisite amount of water following the instruction on the body of the nutrient agar, and then you autoclave it. You cover it up, you seal it with aluminium foil. Use any of the glassware that will take, maybe, I don't know the quantity of media you want to prepare. Usually, when I was still working in the lab, I'll prepare like 200 mils worth, because I want to prepare so that I can use for subsequent analysis maybe the day after. So you prepare that, put it in the autoclave, sterilize it, allow to cool. inoculate your petri dish with a ml or sometimes 0.01 ml of that water that you collected using into the petri dish. Then you pour some of your agar, the specific agar that you are using, you understand? Swirl a little, turn it this way, turn it that way, and then you allow it to set. After setting, put it into the oven or the incubator, better yet. The incubator, increase the temperature because it is bacteria, you increase the temperature to about 32 to 35 degrees centigrade. If you are checking for fungi, the temperature should be at 25 degrees centigrade. You know how fungi grows at room temperature now. You know, then fungi, for instance, you can find that easily if I don't know if any of us is maybe wondering how fungi looks like. That mold that you see growing on eba after the 3rd day or on bread, that's your mold of fungi. So water analysis, so you bring it out after for the, if you are checking for bacteria, you leave it in the incubator for 72 hours. For fungi, you leave fungi for 72 hours. For bacteria, you leave it for 48 hours. 48 hours is enough for bacteria. So water analysis is essential for a wide range of applications, including drinking water safety, wastewater treatment, environmental monitoring, industrial processes and research. The results of wastewater analysis provide valuable information in decision-making, regulatory compliance, and ensuring the protection of public health and the environment. Yes, just because maybe you are into the production of water, or what your production process involves a generation of wastewater. There's hardly any production process that does not involve wastewater. You have to do wastewater analysis because environmental agencies will come. They will come to check the outlets through which your wastewater is flowing into the environment. You're supposed to have treated that wastewater so it will not be a menace to the environment. It will not cause any form of environmental degradation or contamination to the environment. So I still remember when I was working with one of the manufacturing companies, and then the regulatory agencies from Lagos State to come take samples from the outlet, the wastewater, where the wastewater, leaves exist. The company I was working in, take samples, check, and tell us, you understand, whether or not maybe we should intensify efforts on our wastewater treatment or not. So, and then if they feel they are not satisfied with the way the company treats the wastewater, then the company will be surcharged. All of this is just to ensure that the environment is not degraded any further. Wastewater plays a crucial role in safeguarding public health. Water testing plays a crucial role in safeguarding public health, protecting the environment, and ensuring the quality and safety of water for various uses. Here are some key reasons highlighting the importance of water testing. Human health protection. Water testing is essential for identifying potential contaminants, pathogens, and chemicals that may pose health risks if consumed or come in contact with the human body. So let me briefly talk about that. So water testing is essential. It is too essential. You can imagine if a company that specializes in the production of saline drip or dextrosaline drip that are given to sick people, for them, maybe those that cannot eat or they've lost a lot of electrolytes, lost a lot of fluid, and you are giving that, because ordinarily you would think it's actually water. It's actually made up of water. It's just that they added some, nutrients into it. You understand? Just to stabilize the patient or the person taking it. You can imagine if that were contaminated. Maybe it had the heterotrophic counts. It should not even have any heterotrophic count. It should not have any count of any form of bacteria or whatever, because it is entering directly into your bloodstream. So that is for those that make into the production of saline drips and all of that, and other drips and other injection water and the like. But we are saying now that even for drinking water, it should be free of disease-causing organisms, because at the end of the day, you understand, it could cause harm. It will cause someone to have diarrhea. It could cause someone, for instance, salmonella typhi will cause one to have typhoid fever, and the person will start, going to toilet, the person is, in fact, it can, I still remember it caused the death of one of my teachers when I was in secondary school. What you just look at as typhoid. Some people even say, is it not ordinary typhoid? You just take, is it ampiclox or something, and amoxicillin. That's the drug of choice. You take, no. Each person's body is different, and each, the immune system is different. So somebody may take that water and fall very ill and even die. Somebody may take the water and just fall ill, and with treatment, could get over it. But the long and short of it all is water that is going in for drinking purposes should be free of all potential contaminants and pathogens and chemicals that can pose health risk. Water that is going in for drinking should not contain arsenic. It should not contain lead. It should not contain so many, chemicals. So, and it should be clear. It should be insipid, and it should be without any odor. So testing ensures that drinking water is safe and free from harmful bacteria, viruses, parasites, heavy metals, pesticides, and other pollutants. Compliance with regulatory standards. Water testing is necessary to comply with local, national, and international regulations and standards set by governmental and regulatory bodies. These standards define acceptable limits for various water quality parameters and contaminants, and regular testing is required to demonstrate compliance. Yes, you have regulatory bodies that always come. NAFDAC will come. You have a manufacturing company, they will come and visit, or you are making, you're into the production of sachet water or bottled water or mineral water. I just saw mineral water a few days ago. I did not know that, that was being packaged also in Nigeria. So different kinds of, but the long and short is regulatory agencies will storm, companies to ensure that they adhere strictly to acceptable standard. They will look at the records, they will quiz the microbiologists, they will quiz the chemists, they will quiz the quality assurance manager, they will even go ahead to quiz the MDC of the company, because you are making water, or you are making food, or you are making drinks that is going out to the public, and it must be free of contaminants by all means. So early detection of water quality issues. Regular water testing helps identify potential issues with water quality early on, enabling prompt corrective actions. You find out that the water is having, maybe you're a microbiologist or a chemist, has some issues. You understand? It has lead, it has arsenic, or maybe it has pathogens in it. So there are corrective actions. You need to go back to your water filtration system, because every organization, every manufacturing company, you have a filtration plant. A filtration plant, one that will take care of odor. You have the carbon plants that will take care of odor. You have that of sand, and you have, all of that supposed to take care of, it goes through filtration. You understand? Before coming out through the tap. So it should be free of any form of microorganism. And some companies even go ahead to even distill the water. Some go ahead to even treat the water, even after going through the filtration system, to treat the water again, to make sure it is free of all manner of pathogens or contaminants. So, and if you find out that there are some chemical parameters that that something is not right, the company will go ahead to construct another borehole in another location, maybe within the company premises, or just so as to get rid of that, ensure that the water coming out from the ground, you understand, is of good quality. So monitoring environmental impact. Water testing is crucial for monitoring the impact of human activities on the environment. Now, like I said earlier, it's a pity, but we are still in the era of open defecation. I am talking to you from Nigeria. We are still having many African countries are, unfortunately, many African countries still indulge or still, practice open defecation, which is, to me, it is one of the greatest sins against humanity, because all of this tends to enter into some water bodies, and some people, unfortunately, still drink water from streams, from rivers, and all of that. So, it shows when you take a sample of water and you discover that it has E. coli, for instance, automatically that human you can judge the kind of human activity that's taking place. That is poo. That means there's fecal contamination in the water. So it helps identify pollution sources. You can trace pollution sources, assess the health of aquatic ecosystems, and ensure compliance with environmental regulations. Testing surface water, groundwater, and other water bodies aids in detecting contamination from industrial discharges. Like I said, all industries, all manufacturing companies, they all have discharges. But what we are saying is the discharges should not affect the environment negatively. So agricultural runoff as well, those that apply, there's this thing, they call it fertilizer, yes. So the runoff from the fertilizer that runs off, off the ground and then goes into our groundwater, then sewage and other sources, sewage water, that wastewater from cooking, from bathing and all other practices. So safe recreational water use. Water testing is essential for ensuring the safety of recreational water bodies, such as swimming pools. You have to check swimming pools as well. I just learned of recent that some people urinate, and namely the male gender urinates in swimming pools. I just heard that, which is, to me, is something else. Of course, they are warned not to do that, but I heard somebody was telling me, a guy was telling me that it's difficult for a male who is swimming not to wee in the pool. Not to wee in the pool. So I don't know about that, but anyway, it's, of course, that pool is automatically contaminated. So water testing is essential for ensuring the safety of recreational water bodies. So swimming pools, you check for that. You check the water quality, lakes, you check the water quality, rivers and beaches. Testing helps assess, but for beaches can be quite dicey, because I'm aware that some beaches, some people discharge sewage into some beaches. So I do not think, there's no way beach, as for passing quality parameters, I think beaches will be very, very, it will be difficult for beaches, any form of beach, any beach anywhere, to pass. So testing helps assess bacterial contamination, levels of harmful algae, and other factors that may affect the well-being of individuals engaging in recreational activities in these water bodies. Industrial and commercial applications. Water quality testing is critical for various industrial and commercial applications. It ensures the suitability of water for processes such as manufacturing, food, and beverage production. Water quality testing is critical for various industrial and commercial applications. It ensures the suitability of water for processes such as manufacturing, food, and beverage production, pharmaceuticals. I think I mentioned this as well. You are manufacturing food, you're manufacturing drugs, you're making saline drip, all of that. Your water must be scrutinized, not just assessed and thoroughly scrutinized, because what you are producing must be safe for human consumption. There was, I was reading an article about, is it bottles of a particular mineral that was contaminated, that had particles in it, and NAFDAC was issuing a warning that we should be careful, that it's a particular batch, and even, stated the batch. I saw it in the pages of papers. You understand? So that's the, I believe the company today, there's a process they call recall. When you've sent out a particular batch of products, and somehow, before you send out that batch, you would have kept a batch. We call it, you'd have kept a sample, out of that batch. It could be 4 bottles. If it's a drink, it could be more than that. You understand? You keep it and you observe it over a space of, maybe the expiry date is 6 months. You keep it, on your shelf, and examine it for the space of 6 months too, just to see, just in case a customer comes in to complain, oh, this, it has changed taste or whatever, and you now bring your own sample and show the customer, no, are you sure maybe it was not tampered with at your end or whatever, but this one specifically had particles. And I'm sure immediately the company put in process what we call a process of recall, where you bring all those samples that are defective, we call them defective samples, you bring them all back. Your sales managers, your sales people are sent to work to bring them all back into the factory. I also want to remind us about for those of us that stay in Nigeria, about there was a titi mixture that was sold for babies at the time. It was manufactured in a company somewhere in Lagos, and the titi mixture happened to be contaminated. You understand? It was contaminated, and then baby started dying. The owner of the company died in the process, going to court. The QA manager was jailed. It was really messy. So I cannot begin to emphasize the importance of checking for all the parameters before you use it in production and before you take it out to be sold. Pharmaceuticals is even more dicey because pharmaceuticals, it's the pharmaceutical company that makes the saline drip, the dextrose saline that goes directly into your bloodstream. When you take that drip, it's taking once vein is looked for, the needle is inserted through the vein, and then the saline drip is passed directly into the person's body. So you can imagine, if it is contaminated, it means the person will just die, just like that. So because it's going directly into the bloodstream. So, and cooling system, what are used also for cooling systems? There was a sensitization that was done by NAFDAC a long time ago. No, I think it was SON, Standard Organization of Nigeria, where they had to start educating the average hawker on the street. Those are hawk minerals, hawk water, hawk different kinds of drinks. You know them, you understand? So they had to sensitize them that the water, even the ice block that you buy and you source and you use for cooling these drinks, they put them in bowls, those hawkers, and put the ice block, put the water and everything, and then put everything in the ice block, that the ice block itself should be drinking water quality. It should be free of all pathogens. So they were educating those that were into the production of the ice block and not sensitizing them that you can't just take water from the river or from any water source available, ice it and start selling. No, it should be of drinking water. It should be of good drinking water quality, as in people should be able to drink that water. Not that you're actually selling it to be drunk, but people should be able to people should be able to drink, ice their drinks in that water, sure, certain that water is free of any microbial contaminant, is free of chemical contaminants. So you maintain product quality and ensure compliance with industry specific regulations. Then the research and data collection. Water testing provides valuable data for research, monitoring long-term trends, and understanding changes in water quality over time. Water testing provides valuable data for research, monitoring long-term trends, and understanding changes in water quality over time. This data contributes to scientific studies, environmental assessment, and the development of strategies for sustainable water management. Like I said, the importance of water cannot be overemphasized. So it needs monitoring, it needs studying for those in research and data collection. So by conducting regular water testing, potential risk and contaminants can be identified. When I was still in manufacturing, we do water testing on a daily. You do water testing on a daily basis so that potential risks and contaminants can be identified. Then appropriate treatment measures can be implemented and necessary actions can be taken to ensure the safety, quality, and sustainability of water sources for both humans and the environment. Thank you so much.
Thank you very much. This is a great session. I think I stopped sharing my screen now. Okay. So, wow, it's a great presentation, and I believe some people have some questions straight away. I think we have less than 1 minute, and there's a question in the chat. I think it says that I need more insights on spectrophotometry and AAS. Are the two methods not the same? Do the two use same medium? So it's a question from the chat. Between spectrophotometry and AAS, what's the difference?
Please, can you come again?
Yeah, the question asks about the difference between spectrophotometry and AAS.
Spectrophotometry can actually be used to measure different parameters. In fact, there are some companies, those that are involved in water manufacturing and all, that just have a spectrophotometer. That's all that they use. So for testing different parameters, in water. So
and that of AAS, so this person wants to know AAS.
Okay.